Today, my guest is Addy Osmani. Addy is a director at Google Cloud AI, where he leads the teams building the developer experience for the entire agentic stack at Google, including the Gemini Enterprise Agent Platform and the Agent Development Kit. He's also an author and has written books on beyond vibe coding and leading effective engineering teams. His team just shipped what I'd like to call the full production agent stack, ADK 2.0, with a new graph-based workflow runtime, Agent CLI, which comes prepackaged with skills so you can easily do things like deploying long-running agents to Cloud Run, the Managed Agents API, Gemini 3.5 Flash, and Anti-Gravity 2.0. But here's why you should stick around for this entire episode. Addy is going to walk us through 3 live demos of building long-running agents. Agents that don't just answer a question and disappear, they persist, they loop, and they close on real work over hours and days. With that said, Addy, welcome to the Agent Factory.
Thank you so much. I'm a really big fan of the show. Thanks for having me.
All right, so let's get into some of these exciting demos that you have planned.
I guess just to set the stage for folks who maybe have heard the term long-running agents, but have maybe not tried to build one or haven't seen one in action. A lot of the agent demos that you see tend to be stateless. You ask, the model will answer, and then the conversation sort of ends. And even if the demo lasts like 10 or 15 minutes, it's still living inside a single context window. And that's going to get filled and then it'll get discarded. A long-running agent is really the opposite. It's an agent that maintains its state across sessions and it operates over a longer period of time. So we're talking hours, days, maybe even weeks at some point. And your unit of work isn't really a prompt. It's a workflow. So the agent itself owns a multi-step process end to end. And before I show you a demo, I want to say there are kind of 3 things that have to be true for all of this to work. The first is that the agent has to truly be able to sleep. It's a lot like a person. It needs to truly be able to sleep. So some of the ideas we might have used before, things like active polling, doesn't need that. You don't want that. You don't want to have a block thread that is just sitting there burning compute. And it also has to be able to be dormant until some sort of external event can wake it up. That might be a webhook, might be a schedule, a human approval, some sort of human interaction, or a tool callback. The next thing that has to be true is that every step kind of has to have a checkpoint. That state that we talked about a lot of things being stateless. State in this case has to be durably persisted on every transition. So, even if your container running all of this crashes, you still want the server to be able to redeploy, and a human can then take whatever number of days to, complete an action. For example, if we were going through, employee onboarding, or we were going through a loan processing setup, however many days it might take for someone to actually complete an action, the agent needs to be able to still pick up exactly where it left off with no hallucinated memory or intermediate steps that ever happened. And the third thing that's important is that the agent can't grade its own work, right? We've seen lots of people use agents where you'll use the same agent to write your code and then the same agent to review your code, right? And I feel like you need a little bit more nuance to your approach there. Research from a number of labs, including Anthropic, has been pretty conclusive in terms of when an agent evaluates its own output, it consistently overrates it. It's almost overconfident about the quality of the outcome. And so you don't want quality to be mediocre. And the state of the art in this kind of setup is really having a 3-agent setup. You want some sort of planner, you want a generator, and you want a separate evaluator that can test your live result. All right, so here's a visual of what long-running agents actually look like. And if we put those 3 ideas together, so durable states, event-driven dormancy, and separated evaluation, you really stop having a chatbot. You have something that's able to complete multi-day workflows, multi-week workflows. There's so much in our lives where we're working with businesses or we're working with other entities, And it just takes a long time because of the nature of the business to get everything done, to get everything signed, to get everything analyzed, to get things checked off. And long-running agents are perfect for helping us compact those workflows and have agents actually work in the background for us, supporting them. Our colleagues Shubham and Eric, just this last week, they released a new blog post called Building Long-Running AI Agents That Never Lose Context with ADK. And this is great. This is open source. You can check it out. And what the tutorial really gives you is a new hire onboarding coordinator agent using this long-running agent pattern. This is something that could run potentially for weeks and weeks. The way that it works is that the agent sends a new person that's onboarding a welcome packet. It then pauses. It can pause for a long time, multiple days, while you're waiting on that new employee to do things like sign their documents, delegate, talk about, the IT provisioning. So maybe you have a sub agent helping with that. You might be waiting another few days for hardware delivery, right? We're trying to get them their laptops. And finally, they might get a personalized day one schedule at the end of all of this. And you want to complete all of these steps using your agents without losing any of your context. Now, I mentioned the importance of, memory, dormancy, multi-agent delegation. All of these same concepts apply here. This is a really great blog post for just being able to get started with something a little bit more nuanced. Now, you'll see a preview of it here. I've actually got this running locally. Let's kick off a fresh onboarding case. I'm going to give it a name, an email, a start date, anything that it kind of requires for us to get started. So what I'm going to do is click New Case and fill in the new hire details and then submit. So we're going to click Start Fresh Case. We have our HR Command Center. We have our employee portal. We can see that there's a few different pieces here. You can see there's a number of actions, right? You have to sign your packet. You've got your hardware, right? Well, that's not something available just yet. And you can see that we've sent the employee a welcome email. It's waiting for their signature. It's waiting for the next employee action. There's an entire workflow that's in place here. So the agent has called our send welcome packet, logging the ADK activity, and then it immediately stops. And it's now in really that dormant state. This is a real deployment. This container could scale. There's no polling loop, no thread spinning, and it's just waiting for an external event. So we can now move on to signing the packet, right? So on the employee portal, the new hire should be able to see their unsigned onboarding packet. And when they're ready, they can go and sign it. So you can see that we have a signed packet here, right? I'm just going to go and sign packet. You can see that we've got our ADK wake, and then it's waiting on hardware delivered. So the key thing to watch there was the UI not, optimistically updating. It was waiting for the ADK resume turn to actually complete in the back end before it shows us anything. And this is really intentional. It proves the long-running pattern is real instead of something that's faked. Once the signed packet appears, we can see the updated state on the HR panel, right? And it should say something along the lines of, the signature has been confirmed. So we see our signed packet has been confirmed. Great stuff. And then it advances to, the IT provisioning phase. So we need to then think about confirming the employee's laptop delivery. And we can simulate the carrier webhook. In production, this would be a real delivery callback from your shipping provider hitting some API endpoint. Here, the employee just clicks, the confirmed laptop delivered. So maybe they just got it in the mail, right? And you can see that our state has once again changed. And we've now got different UI here, right? We've got our day one schedule. So just to recap that sequence, the hardware delivery receipt appears, then it automatically transitions to that day one schedule. And that ordering is very intentional. The agent runs the steps in the sequence that the state machine dictates, and it can't be coerced into skipping ahead. So that's all great. Now, three things that make this pattern different from that standard chatbot agent I keep bringing up is that durable memory schema. State is an enum in a database. It's not just raw JSON chat logs in some vector store. There isn't context pollution, so we shouldn't have token bloat after weeks of idle time. And second, we've got that event-driven dormancy. The agent isn't, continuously running between those pause gates. It's fully at rest. It's sleeping. And third, multi-agent delegation. When the coordinator needed to provision IT accounts, it didn't do it alone. It was able to delegate to a specialized sub-agent and keep each agent targeted with the reasoning chain still being very clean. So this all looks great. As a reminder, this is completely open source. We'll make sure to link you up to this repo so you can go and you can check out the full setup. It's also got a front end that you can customize to your own needs, but this is a great example, and I definitely recommend checking it out.
Addy, this is fascinating, and I can see a lot of the developers watching this wanting to get their hands on this and start playing around with it already. And I'm sure when using this in real life, you'll have different employees trying to onboard. Like, for example, an engineer would need GitHub access, or a designer would need Figma. But I feel like that's something that could easily be extrapolated on top of this.
Absolutely. As part of this process, you could check on things such as, what role does the person have? And then pattern match to, okay, well, a designer is probably going to require access to Figma, maybe other specific plugins for the agents that they're using. And you can customize this process a lot to make sure that the employee gets the most relevant information for them.
And how easy would it be to incorporate something like the skills registry to this?
It should be fairly straightforward to incorporate the skills registry with this. I think that what folks will find is that a lot of the primitives that have been used to show this will map directly back there. And we actually just released a ton of great documentation about the skills registry that you can use to follow up.
Awesome. I'll be linking that in the description box below.
Now, for something a little bit different, coding is really the canonical long-running workload, if you think about it. Real software usually isn't just built with a single prompt. It's usually a chain of dependent problems, and each of them can fail in ways which the prompt maybe didn't necessarily anticipate, right? So chatbot-style coding can end up failing the first time something really breaks, and it can give up as soon as you run into something really, really complicated. And you don't want it to just hallucinate a fix. You want it to be able to self-correct, move on, continue working until it's able to accomplish your goal, right? For my first demo of long-running agents coding, I gave a coding agent, I gave Claude Code. I'm a big fan of lots of different coding agents, but I also like Claude Code. I gave it a single spec and one instruction. I was able to use their goal primitive for this. So it was able to keep working turn after turn until the goal was met. And it was able to build a simple operating system for me. Because I'm completely egotistical, I've called it Addy OS. I'm sure there's a better name for it. But it's going to have a window manager, an IndexedDB file system, a terminal, a file explorer, and a few other bits and pieces. So I just want to show you this in action. So let's see. So I want to show you this in action. And the first thing we've got here is our terminal. So I expect to be able to do a few things in this terminal. I expect to be able to open up files. Here you can see that my simple operating system was able to open up this text editor, right? And I'm able to, continue typing in here. I can say whatever I want. I can create new documents. I can save documents. And you'll see that it even has a path. It's counting characters and stuff like this. This is very simple stuff, right? We can see that, if I wanted to make these larger or smaller, my small operating system also supports that. And we've, of course, got a file browser in here. I don't have a lot of files right now, but I'm able to go and open files up as well, which is kind of neat. Of course, an operating system wouldn't be complete without some way to, draw. And so I just wanted to be able to do this as well. So we've got a functional, paint application in here as well that's got a lot of other features in it. One small thing, we mentioned at I/O, we were talking at Google I/O, we talked about how anti-gravity was being used to build an operating system. And as we know, an operating system can't be complete if you can't run something like Doom on it. And so my little operating system also has its own version of Doom. So I can walk around this whole environment. I can go and I can, I'm not very good at this, but I've got a whole game here that is working, which is kind of neat. And you can take this as far as you want. Again, this was something that was running for hours and hours, generating a lot of code. Now, this operating system wouldn't be complete if it didn't have a way to play music. I'm a big music fan, and so I wanted it to also be able to do this. Let's see if this works. Oh, that's pretty. I remember when I was growing up, we had operating systems that had these beautiful like music visualizers, and so I'm so stoked that this works. We can also try it out with other tracks and see if we get like slightly different effects here. Oh, that's trippy. Very, very cool. So that's really my first example of a long-running agent that's able to generate something that's non-trivial with a lot of code and a level of complexity around it. Now, if you're not convinced, I wanted to show you something even more complex. So for our last demo, I want to show you something really cool. I am not a game designer or a game developer. I'm not an expert at Blender, but I love the idea of being able to take ideas and bring them to life through agents. And so there's a use case that I had in mind that I think long-running agents really handle well. And it's being able to build a complex 3D scene that you can walk around. I remember when I was growing up, I was a big fan of video stores. You know, the ones where you'd go in and you'd be able to rent a VHS tape or a DVD. Maybe some folks, out there remember those. Now, I wanted to recreate that experience in a way where I could walk around one of those stores and feel that nostalgia. Now, this is a really complicated task because even if I start out with a building, a building that maybe, I pulled off the internet with a 3D asset, there's still a lot of detail inside of the store that I need to handle. I need to build out. I need to get these assets all in the right places. You need to handle things like lighting. You need to make sure that if you want all of this to work in the browser so you can walk around it, your assets are properly optimized. And if you're doing a lot of compression, that things still look good, that you're not corrupting any of the files that are being loaded up, and that everything is loading up in an efficient way too. So there are a lot of challenges around this that I want to talk you through. The first one is that my project here started off with a very, very large Blender file. I had something I was able to pull off the web as a starting point. It was a simple starting point, but still a starting point. And that starting point was 156 megs in size. It was huge. Now, when you have something this big, right, it requires you to rethink how you're approaching the project entirely, because really you don't want to load more than like 5 or 10 megs in the browser. You don't want to keep a person waiting around for a very long amount of time, right? And so this is something where I thought there would be a lot of work, right? This is what our 3D scene ended up looking like in Blender. Again, I'm not an expert, but I can use my agent to continue working on the scene, building out the scene, building out the shelves, building out the tapes, building out everything else that I need in order to make the scene feel complete. But even then, we can run into challenges, right? Because 156 megs, that's going to include your geometry, your textures, your materials. And so if you want to make it browsable, you need to do a lot of optimization. So before I show you this, I want to talk through the problems really quickly. The agent had to solve a chain of hard technical problems, and it couldn't skip any of them. First was our export pipeline, right? Again, I'm not a Blender expert. I wanted this to work in the browser. It had to figure out how to do that, how to handle Blender's Draco quantization without corrupting our geometry on different meshes with different transforms that were being used. So the agent decided to write some Python scripts to fix that. The second was optimization. It built out a pipeline that could handle these GLTF files. If you've worked with 3D, you know what GLTF is. But basically, think of like a file, an asset, as potentially being in a GLTF format. And it had to handle compressing that giant file and all of the other files that made up this scene into something that could, be loaded, be lazy loaded fairly quickly. And it had to make sure that as we were doing texture resizing, image compression, image conversion, all of this still looked pretty good. And the third thing it had to do was handle lighting. So Blender area lights could be exported with extreme intensities, and they didn't necessarily by default look good in the browser. There's a particular look and feel that, a video store used to have. And I wanted that to feel pretty faithful. And so the agent was able to keep working through a lot of these problems. It was able to make sure that our material colors were correct, our mixed shaders were right, that this faithfully reproduced the kind of look and feel of the original scene that we wanted to show you. And so I'm going to actually bring this up and you can take a look and see what you think. So here is our scene. And I'm going to go and I'm going to walk in to our classic video store. You'll see there's a lot of detail here, right? You can see that over here, I've got the mat. I've got the central desk experience where I could go and I could, hand in the videos that I want to either return or pick up. You can see that we have a lot of extra detail here that I'd included in my spec. Things like, oh, well, I'd kind of love some cardboard cutout posters that we could have around the store. There was a mascot that the store also used to have. You can see T-shirts. You can see chocolate bars over here. We can go and we can look at the videotapes that are on these different sort of shelves. It looks a lot like, a classic video store. We've also got like a little area over here where people can go and they can sit down. We move around our scene and let's see what else we've got. We've got some other pieces. We've got what looks like, let's see, let me move around here. We've got more swag. We've got a Back to the Future display here. A lot of these things are things that were in my original spec. We've got Indiana Jones. We've got some horror icons here as well. This is all very, very cool. And once again, I am not a Blender expert. I'm not, necessarily a person that would have been able to build out a scene as complex as this and have it just work in the browser without it taking a long time to load. And so I thought this was very cool. I thought that, agents being able to churn at this for hours and hours and hours. And in the end, it ended up taking, more than a day. I believe it was 2 or 3 days in the end for it to fully get everything done. But this ends up looking really, really cool. And so I think that long-running agents have a lot of promise where coding is concerned.
Addy, thank you so much for all of these amazing agentic scenarios, from agents which monitor the internet around the clock, onboard employees across a dozen systems, and then also spinning up an entire game in Blender. All of this being long-running agents built entirely on Google's Agentic stack.
You're welcome. I hope folks find something in there useful.
I want to shift gears slightly. So there's a real tension in the developer community right now. On Hacker News recently, a post titled, "I'm going back to writing code by hand," hit 800 plus upvotes. Right next to it was a post titled, "An AI coding agent needs to reduce your maintenance cost, not just write code faster." And then another comment which received 1,600 upvotes was, local AI needs to be the norm. So you wrote a book called Beyond Vibe Coding. What do you say to developers who feel like AI is actually creating more debt than value, or that they're losing their craft?
Yeah, this is a really great question. I tend to see a lot of productivity gains from using agentic engineering, but it also comes with a number of things that we have to keep in mind if we're to continue the craft of building high quality software. One of those first things is remembering that just having higher velocity output is not enough, right? If you're using an agent to build you software, to build you features, you as a human, as a senior engineer, need to be able to verify that that output is correct. People might have very strong opinions about what that means, right? Maybe that means having a very extensive set of tests. Maybe it means having visual regression testing. Maybe it means just having a very clear idea of what good means, so that when you're using agents to build more code, to build out more features, they can at least check that they are not going far off the rails. I also think it's very important to be, very intentional about how we think about code review. Very often, again, this is a polarizing topic. There are opinions we'll hear very often that are painted in broad strokes. Like, for example, we will sometimes hear folks say, well, I don't need to review the code anymore, right? If something goes wrong, I'm just going to have my agent fix it. And very often, that's a That's a position, but that position often comes from folks who are one-person founders or small-person teams. They're creating something evergreen. Maybe it doesn't have a lot of users to start off with. And so their approach to verification, their approach to how they work with agents can differ quite a lot from a team that is maintaining, either a legacy application or something very large that already has a lot of users, and where being a little bit more Wild West with how you use agents is not going to fly, because you need, you're expected to provide a stable, reliable experience. And so I think it's important just to keep in mind that there's a little bit of a spectrum here of options that people can use. There are also a few things that I've recently been talking about that I think can maybe resonate with folks. The first is cognitive debt. As we increasingly use agents for coding and for other tasks, we can see an erosion of our memory and our skills around how we tackle problems, because we're increasingly just deferring to the agents to do the thing. And our current tools are very optimized for just accomplishing a goal. So let's you give it a spec, let's get that spec built for you. Let's help you get to the end product. They're not really optimized for learning, for understanding, for having a good idea of how that house of cards, hopefully it's not a house of cards, but how that house of cards is constructed. And if you follow up from comprehension debt, you end up comprehension debt or cognitive debt, you end up with cognitive surrender. And cognitive surrender is where you're no longer critical thinking. You're just deferring entirely to your agents, and whatever output they give is the output that you ship. And that's a big challenge, because if there comes a time when your agent is not able to help you with a fix, or production goes down and your agent is not exactly sure like why it is, you don't want to be in a situation where you don't really understand how all those Lego bricks making up your code base connect, how they work, why certain decisions were made. And so I think it's important for us as engineers to understand agents, coding agents, agentic engineering, really powerful. I genuinely believe they offer a great deal of value. I have personally never felt more productive, and also never more tired. Like I feel like a lot of us are just running lots of agents and always have guilt if we're not running agents in the background. And so I think people just need to be very mindful about taking this additional power that we have and making sure that we're not just delegating entirely to the agent. And so we're keeping that human in the loop. Because even at best, if you're building something meaningful today, I would say agents can get you 70% of the way there, maybe 80% of the way there now. But that 20%, that 30% that's left, is where your human judgment still has to come in, where your understanding of the fundamentals, your understanding of what good quality means comes in. And so I hope that folks take something from that's of value.
You also published the Agentic Engine Optimization Framework, the first standard for making documentation consumable by AI agents. We saw how skill registry and tool definitions depend on well-structured interfaces. So is AEO going to be just as important for the agentic era as SEO was for the search era? How should teams be thinking about this today?
Great question. I think it ultimately depends on where you see your users interacting with your experience the most. So when I think about agent engine optimization or agentic, content optimization, it's often from the lens of someone that has to think about developer experience and developer documentation and how we can get you the most insight, the most knowledge, the most skills to help you better accomplish your tasks. And so I think that if you are building a developer product, having a solution that makes it easier for agents to go in, understand your stack, understand how they can build on behalf of the developer is really, really powerful. And if you're not doing that, I think that's a big opportunity you might be missing out on. If you are building, if you're a content author, a publisher, a platform, and you are publishing something today where you're not entirely sure, like, hey, are we still a little bit early where we don't know if people are going to be mainly using, search in the same way, or are they going to be using a chat interface to interact with the internet? I would say that just trying to make sure that the best practices we've been giving people over the last couple of years, make sure that your site can easily be read, easily be loaded, supports good accessibility. All of those things will still benefit agents. I wouldn't say that it's a slam dunk case that every single website has to optimize for an agent experience today. Developers are early adopters around all of this. So I think that it makes a lot of sense, because if I'm using anti-gravity, if I'm using Claude Code, if I'm using any of these tools, I benefit from my agent being able to understand the docs. I may not necessarily need that for other kinds of sites. And so that's how I would think about it. Pay some attention to how agents might consume your content on your site. But if you're not targeting developers, just make sure that you are keeping an eye on how that traffic pattern around people using a chat interface maybe influences your site over time, and then invest accordingly.
Final question, the one I ask every guest: what is the one tool, framework, or workflow that you could never give up?
The one tool or framework I could never give up. Oof.
I know it's tough.
I'm gonna cheat and say the browser. I do so much inside the browser every single day. It's how I access all of my AI tools, including sometimes my agent management tools. So the browser.
Awesome. Addy, this has been an incredible episode, from the IO 2026 releases we talked about, to the beyond vibe coding philosophy, to seeing long-running agents that actually run for days and coordinate like teams. Thank you for coming on to the Agent Factory and showing us what production-grade agents really look like.
Of course. Thank you so much for having me. This is a great conversation, and I hope that folks check out some of the material that we talked about today.
Everything we talked about is linked in the description box. Agent Studio, ADK, the IO 2026 releases, as well as Addy's social, so you can connect with him there. If this episode changed how you think about building AI agents, if you're ready to go beyond vibe coding, hit the subscribe button to stay up to date with Google Cloud Tech. And then also drop a comment. What's the first long-running agent you would build? If you want to watch more about Agent CLI, check out this video right here. And if you want to learn more about Google's new AI-powered UI tool, Stitch, check out this video right here.